Good morning to you. Our topic for today are the different types of memory used in a computer. Let's get to know first what are the computer's primary memory. Primary memory is the computer's memory that is accessed directly by the CPU, or the central processing unit. This includes RAM or random access memory, and ROM or read-only memory. Random access memory is a hardware device that enables the storing and retrieval of information on a computer, but since it's a volatile type, it does not save everything when his computer turned off. This is how RAM works. If you are to open a certain application or file, the central processing unit will ask RAM to get the saved files. RAM will then get the files from the hard drive and back to the CPU. If the memory of RAM is low, some part of the file should be kept on the hard drive, and repeat the process until all the files is all sent to the CPU. To solve this problem, we need to increase the memory of RAM to accommodate more files. This will increase the file transfer from the hard drive to the CPU, thus making the computer run faster. Here are the types of RAM. DRAM or dynamic RAM is the most commonly used type of RAM in computers. The common types of DRAM are SDRAM or synchronous DRAM. It synchronizes the memory speed with CPU clock speed so that the memory controller knows the exact clock cycle when the requested data will be ready. This allows the CPU to perform more instructions at a given time. Typical SDRAM transfers data at speeds up to 133 MHz. RDRAM or Rambus DRAM takes its name after the company that made it, Rambus. It was popular in the early 2000s and was mainly used for video game devices and graphics cards, with transfer speeds up to 1 GHz. DDR-SDRAM or double data rate SDRAM is a type of synchronous memory that nearly doubles the bandwidth of a single data rate SDRAM running at the same clock frequency. By employing a method called double pumping, which allows transfer of data on both the rising and falling edges of the clock signal without any increase in clock frequency. DDR1 SDRAM has been succeeded by DDR2, DDR3, and most recently, DDR4 SDRAM. Although operating on the same principles, the modules are not backward compatible. Each generation delivers higher transfer rates and faster performance. The latest DDR4 modules, for example, feature fast transfer rates at 2133, 2400, 2666, and even 3200 mega transfer per second. ROM or read-only memory is a non-volatile type of memory, which means any data stored will stay even there no power or computer is off. It stores data that should not be electronically altered or modified after manufacturing. ROM stores softwares called firmwares. Firmware allows the hardware to communicate correctly with the operating system. It also contains the basic input and output system, or BIOS of the computer. It is the built-in core processor software, responsible for booting up your system after it is powered on. To fully understand how ROM works, let's have an example. If you were to eat your favorite food, before you eat it, your brain is processing the smell and the taste of the food. It is the same as the ROM. Your BIOS contains the bootstrap which guide your computer from power on, through series of steps before the OS or operating system loads. We also have the secondary memory storage drive. Secondary memory is not accessed directly by the CPU. Instead, data accessed from secondary memory is first loaded into RAM and is then sent to the processor. Here are some types of secondary memory: solid-state storage, optical storage, and magnetic storage. Magnetic storage encodes data through positive and negative magnetic polarity. Through magnetizing platters in positive and negative polarities, the pattern are stored in form of bits. Example of this are hard drive or hard disk drive, floppy disk, magnetic tape, magnetic drum, zip diskette, super disk, and MRAM or magnetorecessive random access memory. We also have solid-state storage. Solid-state storage is composed of silicon microchips where it can be written to and overwritten like RAM. However, unlike RAM, it is non-volatile, retain its content even the computer is switched off. Good thing about this is being portable and produces less heat than traditional storage drives. It is also a type of computer storage media that stores data electronically and has no moving parts. Here are some examples of solid-state storage: flash memory, USB memory stick, memory cards, smart cards, multimedia cards, and memory stick media. Lastly, we have the optical storage. Optical storage is an electronic storage medium that uses low-power laser beams to record and retrieve digital binary data. In optical storage technology, a laser beam encodes digital data onto an optical medium. Here are examples of optical storage devices: compact disc read-only memory or CD-ROM, digital versatile disc read-only memory or DVD-ROM, digital versatile disc random access memory or DVD-RAM, write-once read many or worm cartridges, removable mass storage or RMS, which are removable disk, and flash drives. For the computer components to work, we have to connect this to the motherboard and other components which are compatible to them. With this said, we will use drive interface. Here are some common drive interface. IDE or Integrated Drive Electronics, EIDE or Enhanced Integrated Drive Electronics, PATA or Parallel Advanced Technology Attachment, SATA or Serial Advanced Technology Attachment, SCSI or Small Computer System Interface. IDE or Integrated Drive Electronics is also called Advanced Technology Attachment or ATA. It is an early drive controller interface that connects computers and hard disk drives. An IDE interface uses a 40-pin connector. EIDE or Enhanced Integrated Drive Electronics, also called Advanced Technology Attachment 2 or ATA2, is an updated version of the IDE drive controller interface. EIDE supports hard drives larger than 512 megabytes. It also enables DMA or direct memory access for speed, and uses the ATA-PI or Advanced Technology Attachment Packet Interface to accommodate optical drives and tape drives on the EIDE bus. An EIDE interface uses a 40-pin connector. PATA or Parallel Advanced Technology Attachment refers to the parallel version of the ATA drive controller interface. As its name implies, it is based on parallel signaling technology. The connections for PATA devices were originally made using 40-conductor ribbon cables. These were later supplanted by 80-conductor cables in which every other conductor is grounded, minimizing mutual capacitance and consequent crosstalk between conductors. The maximum workable cable length is 46 centimeters, which is about 18 inches. This means that PATA cables are only practical for use with internal drives. SATA or Serial Advanced Technology Attachment refers to the serial version of the ATA drive controller interface. It is an interface used to connect ATA hard drives to a computer's motherboard. SATA transfer rates start at 150 Mbps, which is significantly faster than even the fastest 100 Mbps ATA per 100 drives. For this and other reasons, serial ATA is likely to replace the previous standard, parallel ATA, which has been around since the 1980s. Besides faster transfer rates, the SATA interface has several advantages over the PATA interface. Serial ATA drives each have their own independent bus, so there is no competition for bandwidth like there is with parallel ATA. They also use smaller, thinner cables, which allows for better airflow inside the computer. SATA cables can be as long as 1 meter, while PATA cables max out at 40 centimeters. This gives manufacturers more liberty when designing the internal layout of their computers. SATA interface uses a 7-pin connector. And lastly, SCSI or Small Computer System Interface. It is a set of standards for physically connecting and transferring data between computers and peripheral devices, such as both input and output devices. It is a drive controller interface that can connect up to 15 drives. SCSI can connect both internal and external drives. It also uses a 50-pin, 68-pin, or 80-pin connector. And those are the memory that are used in computer. If I have missed some, please do comment it, and I would love to answer them for you.